Good evening, students. I am Shivashankar. Today, I am going to explain to you alcohols, phenols, and ethyl. In the topic, some important questions I am going to explain to you. Here, the first question is the product obtained from the reaction is. If you see here phenol is given and sodium hydroxide, carbon dioxide hydrolysis is given. So by seeing this reaction is named reaction. What is that named reaction means? It is coal-base reaction. In this coal-base reaction. In this reaction, what's happening means that phenol, when it is reacting with the phenol, when it is reacts with NaOH, that phenol, when it's react with NaOH, the first we will get it sodium phenoxide ion. What you are getting here? Sodium phenoxide ion, like this, where here O minus, here Na plus, like that I will get, okay, sodium phenoxide ion. This one, when it is reacting with carbon dioxide, there we can get what is that sodium phenoxide ion. This one in this ortho position COONA. And this substance, when it is undergoing acid hydrolysis, there you can get OH and COOH, like that. This substance, ortho hydroxy benzoic acid, what is it called? Salicylic acid. What is it called? This one is called salicylic acid. It is called salicylic acid. Okay, like that, phenol, when it is reacting with NaOH, CO2 hydrolysis, there we are getting this salicylic acid we are getting. Okay, that reaction, named reaction is Kolb's reaction. Next question. Picric acid. Picric acid is, what is picric acid mean? Here phenol, when you take it phenol, the phenol, when it is having a second position, okay, second position, fourth positions, and the sixth position nitro groups, like that nitro groups are there means this is called picric acid. It is also called 2,4,6 trinitrophenol. It is also called 2,4,6 trinitrophenol. Okay, so this one is called picric acid. Next question. Lucas reagent. What is Lucas reagent? A Lucas reagent means, okay, concentrated HCl and anhydrous ZnCl2. This mixture is called Lucas reagent. Concentrated HCl and anhydrous ZnCl2. This mixture is called Lucas reagent. What is the use of this Lucas reagent means? To distinguish primary, secondary, tertiary alcohols. It can easily detect alcohols. Your second question in this next question only is there. Lucas test is used for the detection of alcohols. Detection of alcohols. What is the use of this one means? Here, primary alcohols, secondary alcohols, and tertiary alcohols. Whenever you are taking tertiary alcohols are highly reactive. So when we add Lucas reagent to tertiary alcohol, immediately this tertiary alcohol is converted to tertiary chloride. So turbidity, white color precipitate, white precipitate will form. That is called turbidity. So immediate reaction takes place. Instead of that one, secondary, if you take it, the secondary alcohol, when it is react Lucas reagent, the secondary chloride will get it, but immediately we don't get it. After 5 minutes we will get it. After 5 minutes. That's why, so tertiary means immediately will give, secondary means after 5 minutes, and primary, if you take in, primary it also gives primary chloride, but at high temperature. At high temperature only it gives primary chloride. At room temperature primary it won't give what is the turbidity. So tertiary alcohol immediately gives turbidity. Secondary alcohols after some time, after 5 minutes it gives. Primary alcohol at room temperature it won't give turbidity. At high temperature this one also can give turbidity. Okay, students, understand? So this is called Lucas reagent. Anhydrous ZnCl2 concentrated HCl is called anhydrous what is it called? Lucas reagent. Next, intramolecular hydrogen bonding is strongest. Where intramolecular hydrogen bond strong will be there? Here, if you take it that this substance A, B, C, D compounds are given. First A is what is that? A is given methylamine. So methylamine. This methylamine. So methylamine can form hydrogen bond, but it cannot form hydrogen bond like oxygen. Okay, And next, formaldehyde. Formaldehyde also, here no, hydrogen is not directly combined with the oxygen, so there is not that much strong hydrogen bond. And phenol, if you take in, so phenol group OH is there, it can able to form hydrogen bond. So this amine also can form hydrogen bond. And D option, methyl alcohol, methanol is given. So this one also can form hydrogen bond. So like that, mostly if you choose which one can form easily hydrogen bond means A, C, D can form hydrogen bond. But here question is what is the intramolecular hydrogen bond is strongest in? Where intermolecular hydrogen is strongest. So which one we have to take it means, okay, we have to take it answer. Okay, what is the D option? Why means comparatively nitrogen, oxygen can form strong hydrogen bond. So maybe answer is in C and D. In the C and D, to form strong hydrogen bond, we require small groups. But here phenol is there. Phenol, the benzene ring bulky group, steric hindrance will work. So due to steric effect, bulky group like benzene bulky group is there, that's why it cannot form that much strong hydrogen bond. Okay, then methyl alcohol small group is there, benzene large group is there, more steric in them. So here methyl alcohol can form strong hydrogen bond. Next question, among the following one which reacts most readily with ethanol is? Ethanol is means these given substance, what are those? If you see here, by seeing this para-nitrobenzyl bromide, that one first one is para-nitrobenzyl CH2Br, para-nitrobenzyl bromide, first one. Okay, this is A. And B, if you take in para-chloro, B is para-chloro benzyl bromide, para-chloro-benzyl bromide. C, if you take in para-methoxy. C, if I take it, what is that? Para-methoxy benzyl bromide. Para-methoxy-benzyl bromide. If I take D, para-methyl. If I take D, what is it here? Para-methyl-benzyl bromide. Para-methyl-benzyl bromide. Like that, four compounds are there, A, B, C, D. In this A, B, C, D, so which is giving more stable carbocation? Which one gives more stable carbocation means here C option can give. Why means here electron donating group is there means stability of carbocation increases. Here OCH3 methyl group, these two are electron donating groups, but in that OCH3 plus some effect, CH3 plus I or hyperconjugation you can take it. So plus some effect is more effective than hyperconjugation inductive effect. So here electron donating nature much is there means okay, stability of carbocation is more. Here NO2 group is electron withdrawing group, this chlorine also electron withdrawing group. So more stable carbocation is given by OCH3 and CH2 plus this substance. So this is, that means that bromine is replaced by ethyl alcohol. Ethyl alcohol here acting as a nucleophile. So here ethyl alcohol, if I take it on ethyl alcohol, like that lone pair is there, this lone pair will attack now this group. Okay, like this, among the following, the one which reacts most readily with ethanol means what we have to take is para-methoxy-benzyl bromide. So right answer C option. Right answer what we can take is C option is right answer. Next. Next question. Propane 1-ol can be prepared from propene by. Propane 1-ol can be prepared by propene. So first I will write equation. If I write equation here, propene, this I am taking propene. Yeah, this propene is converted into propane 1-ol. Propane 1-ol means here 1, 2, 3, here 1, 2, 3. Okay, so one known we got it. That means that addition reaction takes place here. Which reaction takes place here? Addition reaction. But OH combined to first carbon, that means it's undergoing anti-Marconic approach. It's undergoing anti-Marconic approach. It undergoes anti-Marconic upstream. It's undergoing anti-Markovnikov rule. Which substance can undergo anti-Markovnikov rule? If you observe this substance, which one give anti-Markovnikov product mean? That is only one, diborane, hydroboration. Okay, alkenes, when those are undergoing hydroboration, whatever product alcohols we are getting, that one gives what is that anti-Markovnikov product. Like that one propanol we got it. Next one. Next, if you take it, the most suitable reagent for the conversion of ethyl alcohol to aldehyde. So most suitable they're asking. Some cases NCERT is given, okay, chromium triacylose, anhydrous chromium triacylose is given. But most suitable means what we have to choose means PCC, pyridinium chlorochromate. Pyridinium chlorochromate, this pyridine, okay, pyridinium chlorochromate. So this substance, okay, which is the best mild oxidizing agent, it can convert alcohol to aldehyde. Okay, so like that you can choose. So answer you can take it here, this one, PCC, pyridinium chlorochromate. Next, the major product formed in the following reaction is, if you see here methyl group is there. In this methyl group, okay, methyl group, here this one, what is that? Primary is there. Primary group is the primary carbon. So in this, if you see here, what will happen means it may undergo elimination is possible, and at the same time nucleophilic substitution also possible. Elimination and nucleophilic substitution also possible. Here base is there, CH3O minus. So I am taking like this. Here what is that? Here conversion. First the substance will be giving primary carbocation. That primary carbocation is converted into, okay, due to give the stable carbocation. Comparatively primary carbocation, tertiary carbocation more stable. So here hydrogen shift. What is happening here? 1,2 hydrogen shift is taking place. 1,2 hydrogen shift is taking place here. Now it takes any one hydrogen, either any one beta hydrogen, either this one or this one. From that you can get it like this. Like that, what you are getting? Isobutene. What you got it? Isobutene you got it. Isobutene we are getting here. Isobutene. Okay, students, understand? So like that, what's happened? First case here, primary carbocation, rearrangement, tertiary carbocation we got it. Next elimination takes place in the presence of this base. So you can choose here answer, this one you can choose. We can choose answer, C option you can choose. Next, the major product obtained on the monobromination Br2 FeBr3 of the following compound is monobromination. So if you observe here, in this case what are there? If you observe this one, in these two components are there. OC benzene is combining with OCH3 and CH3. Both are electron donating groups. OCH3 also electron donating group with respect to plus M. Methyl group also electron donating group with respect to plus I, or what is that, hyperconjugation also we can take it. So if you observe this one here, plus I effect, if I take it, methyl group shows inductive effect. The length increases, distance increases, what is the inductive effect? Decreases. But methoxy group, plus M group, what is that? Resonance effect. Distance increases, there is no change in what is that? Resonance effect. So here this one will affect at ortho and para position. Methoxy group giving electrons to ortho and para position, and methoxy group giving electrons to ortho and para position. Methyl group also giving electrons to ortho and para position. For both groups, ortho and para position same, here. Okay, so now here where that monobromination means Br plus from FeBr3 from FeBr3 plus Br2, which substance will get it here? FeBr4 minus plus Br plus. Like that electrophile will be produced. That electrophile will attack at either ortho or para positions, like this, either ortho or para positions attacking those, either other para positions attacking. So here what is that? Here that Br it won't attack in this place. Here, okay, not possible. Reason steric hindrance. Steric hindrance. Okay, in this place more steric hindrance is there, so that place not possible. And next either this place or this place. So methoxy group giving more electrons to either this place and this place also, so no problem. Why means resonance effect equally to ortho and para position. But methyl group is inductive effect, it's showing it gives more electrons to ortho position. Why means near position, less electrons to far position. So methyl group giving more electrons to this position, less electron to this. So that Br plus should attack at which position here? This position. So which substance is possible? If we try to get that compound is OCH3. OCH3, here CH3, here Br will attack here. Okay, so like that answer we can choose. What is that? B option we can take it. This is answer. This is B option is the right answer. Okay, next question. Next one if you see. Next one here methoxy. What is given compounds here? Methoxy, ethane and tertiary butyl methyl ether are treated with hydroiodic acid. The fragments obtained after reactions are. Here if you take this one, very important, this model here. Here what is that? In that ether, when it is undergoing decomposition, if it is able to provide stable carbocation, it gives it will undergo SN1 mechanism. It's not able to provide stable carbocation, it follows SN2 mechanism. So SN2 mechanism means smallest group will undergo nucleophilic substitution. That means combined with iodine. So first group if you take it here, in this not possible to give. Here it's not possible to provide what is that stable carbocation. So it will undergo what is it? Nucleophilic substitution, SN2 mechanism. This is undergoing SN2 mechanism. Iodine combined with here, I combined with here. So iodine combining here, hydrogen combined with this here. There we are getting methyl iodide and ethyl alcohol. Methyl iodide and ethyl alcohol we will get. Second compound if you take it, in this second compound, this tertiary butyl, stable carbocation can possible. So that's why here what it's undergoing homolytic, that means cleavage to provide iodine and here hydrogen. So like that here it can provide stable carbocation undergoing SN1 mechanism. So there you will get it tertiary butyl iodide and methyl alcohol. So right answer will be this one. Right answer is this. Okay, so if it's able to provide stable carbocation, that ether when it is undergoing decomposition, able to provide stable carbocation, SN1 mechanism. Not able to provide stable carbocation, SN2 mechanism. Okay, that way the ether will undergo decomposition. Okay, students. Next question if you take in, which of the following reactions the product obtained is the tertiary butyl methyl ether. Tertiary butyl methyl ether. Okay, now if you take it this one, concentrated H2SO4 is given. When you take it this concentrated H2SO4 and methyl alcohol, ethyl alcohol, you may get ether. Which ether you can get it here? Like this, CH3O C2H5. Methoxy ethane you can get it. Otherwise, here, okay, methoxy methane. Otherwise, ethoxy ethane. Like the three combinations, any three combination. These three combinations, any one. But tertiary butyl methyl ether not possible. And next, second case if you take it. Second case, here methyl alcohol is there. Here methyl alcohol and here what is it? Tertiary butyl bromide is there. Alcoholic KOH like that, alcoholic NaOH. So in the presence of that, more react to alkyl halide undergoing dehydrohalogenation and it provides isobutane. CH3 C double bond CH2, here bond CH3. Like that, we are getting here isobutene. What we are getting here? Isobutene we are getting. So that is, this substance is, what is that? Alcoholic NaOH. Alcoholic NaOH. It is dehydrobromination. Okay, like this. Second one, if you take it. So in this case also, if you observe here, alkyl halide and potassium tertiary butoxide is there. Sodium tertiary butoxide is there. Here, this is very strong base, but here very weak alkyl bromide. That's why no elimination. So you can expect here, we got the tertiary butyl methyl ether. So here we can expect compound like this. Here CH3, CH3 and CH3. Like this we can expect here tertiary butyl methyl ether. Tertiary butyl methyl ether. And next, the fourth case if you take in, it is sodium methoxide. It is tertiary butyl methyl ether. So when those two reacting each other, it is highly reactive one. So that's why in the presence of this base, this substance will undergo dehydrohallucination. It's giving isobutene. It gives, what is that? Isobutene. Like this. This substance is giving isobutene. Like this. Okay, students. Next, which of the following is a primary halide? To know that primary halide, what is primary halide? Carbon which is combining with one carbon, that carbon only combining with the halogen. That one is called primary halide. Isopropyl. First I am taking isopropyl. Isopropyl iodide. Iso meaning which is compound which is having like this carbon which is combined with two groups. Carbon which is combining with two groups. Carbon which is combining with two methyl group. That one is called iso. Isopropyl means total 3 carbons. Isopropyl iodide. Isopropyl iodide, you can get it. Okay, here this is what is the secondary carbon. This one is secondary carbon. Okay, secondary carbon, secondary halide. Next, if you take in secondary butyl iodide. Secondary butyl iodide means, so butyl group right here, it is secondary carbon. Secondary carbon means this one should combine with iodine. It is secondary butyl iodide. See, if you take it tertiary butyl iodide. It is tertiary butyl group, here bromine. Tertiary butyl bromide. It is, what is the carbon here? Tertiary carbon, that is tertiary halide. And D option, if you take it, neohexyl. Neo group means like this, you have to take it. It is neopentyl. Hexyl means like this. Neohexyl chloride. So in this this hybridization, this is primary carbon. Primary carbon, that carbon is combined with halogen. So what is it here? Primary halide. Primary halide, you can take it. Neohexyl chloride. So here, what is that question here? Which of the following is a primary halide? What we can take it? Neohexyl chloride having what is that? Primary halide. So this one answer. Next question. Next question here. Next one, if you see an organic compound Exxon treatment with pyridinium chlorochromate in dichloromethane gives compound Y. One X compound. Here what's happening here? One X compound is there here. That X compound, when it is reactive with the pyridinium chlorochromate, that meaning what is that? PCC, in the presence of dichloromethane, it is giving compound Y. This compound Y, when it is reacting with I2 and NaOH, I2 and NaOH, there we are getting iodoform, CHI3. Like that, iodoform we got it. CH means iodoform. So what is X? X means here PCC we are using. PCC, whenever you are using, your alcohols converted into aldehyde. So that X must be ethyl alcohol. X, whenever you are taking ethyl alcohol, there we will get it acetaldehyde. That acetaldehyde, when it is undergoing iodoform reaction, there we are getting iodoform plus formate, sodium formate, like this substance you can get. So right answer, what we can choose here, in this right answer you can choose this option. Ethyl alcohol is right answer. Okay, next question. Next one. The formation of diethyl ether from ethanol is based on. So what is that? Diethyl ether is forming from ethyl alcohol. So C2H5OH and C2H5OH. This one is giving diethyl ether. C2H5O, C2H5, like the diethyl ether we are getting. Here what's going out in this H2O, water is going out like this, dehydration. So diethyl ether. That means this process is called dehydration. What is it called here? Dehydration reaction. This reaction is called dehydration reaction. Next, chloropicrin. Chloropicrin is obtained by the reaction of. What is chloropicrin here? Okay, CCl3NO2. This group is called chloropicrin. How we'll get this substance? When chloroform CHCl3. This chloroform, what is that? CHCl3 plus HNO3. When these two reacting each other, chloroform is giving H and HNO3 losing OH. So when chloroform loses H and HNO3 lost OH, their H2O is coming out. Remaining products, what are those? CCl3. From HNO3 OH, if you remove, NO2 will be there. Okay, like the CCl3 and water. This substance is called chloropicrin. It is also called tear gas. So what is reaction here? So nitric acid and chloroform. Nitric acid and chloroform. This reaction is giving what is chloropicrin. Next, ethanol can be prepared more easily by which reaction? Ethanol. So ethyl bromide, when it is reacting with what is that, aqueous KOH, there you can get ethyl alcohol. But what is given here? H2O is given. So first is not possible. First is not possible to give what is that, alcohol. Second one, ethyl bromide reacting with silver oxide in boiling water. Here silver oxide, when it is reacting with water, hot water, it's converted into silver hydroxide. It's converted into silver hydroxide. When it is converted into silver hydroxide, now this substance, when it is reacting with ethyl bromide, what will happen? This Br is replaced by OH. Nucleophilic substitution, SN reactions takes place. There you can get it ethyl alcohol. So 2 is right answer. What we have to take in by 2. This one 2 is right answer, not 1. Next, an aromatic ether is not cleaved by HI even at 525 Kelvin. The compound is. So here ether, any ether, when those are reacting with HI, what is happening? Like this bond cleavage takes place. Here H, here iodine, like that R bond I and alcohol will get it. But aromatic compound like this, whenever you're taking, so not cleaved by HI, they're telling, at high temperature also. That means ether is formed by 2 aromatic rings like this. So when it is reacting with HI, what will happen here? In this case, what is happening? So these electrons are involved in resonance with this one and this one. So these bonds getting double bond character, very difficult to break. So here no reaction. So we don't get it. So answer you can choose. This one we can take C6H5 or C6H5. Okay, diphenyl ether you can take it. Aromatic ether is not cleaved by HI even at 525 Kelvin. The compound is diphenyl ether. Remaining all will give the substance. Next, the product of the following reaction is. Here already starting we discussed BF3 alkene is given, BH3 hydrogen peroxide means anti-Marconic of role. The product will be anti-Marconic of role. Like this you will get it. Like that you are getting here. So 1, 2, 3, 4, 5. So this is pent 1-ol. This is what is a pent 1-ol. So answer is this one, you can take it. Okay students, so these are the topics here. Thank you very much.